Hello guys, in this video we are going to discuss the solution of the problem maximum index. So let us look at the problem statement. The problem statement says that given an array A of n positive integers, the task is to find the maximum of j minus I subjected to the constraint ai is less than or equals to aj. So we need to find the maximum of j minus I subjected to this constraint. Okay. So let us try to understand the problem statement with the help of an example. So let us take an example where the number of elements given to us is 9. So n which is given to us is 9 and the elements of the array ARR are, so these are the elements which are given to us, and given this we need to find the maximum value of I minus j such that AI is less than or equals to AJ. Okay. So here in this particular case, and this ARR is also array A. So in this particular case, if we see A1 is equals to 8 and A7 is equals to, so let me write down the indexes as well. So these are the indexes and A7 is 33. Given this, A1 is less than or equals to A7 and the difference between I minus j in this particular case, this is equals to, I'm sorry guys, this is basically not I minus j, this should be j minus I. So this is a correction here, and because of which the difference between j minus I will be equals to 7 minus 1, which is equals to 6, and in this particular case 6 is what we are going to return. So this is our answer. Okay, so that's about the problem statement, folks. Now let us discuss the brute force solution for this before we jump into the optimal solution. So let us discuss the brute force solution for this. Well, the brute force solution is pretty straightforward. What we need to do is we need to generate all possible pairs. And let us say that these possible pairs are stored in a variable x. Now we are going to iterate on x and we are going to check whether ai is less than or equals to aj. If it is, and this x contains elements such as I comma j, okay, and if this is the case, then I'm going to compute the difference between j minus I and I'm going to store the maximum of this difference in a variable which is our answer. Okay, and towards the end this answer is what we are going to return. So that's about the brute force solution, folks. Now let us discuss the running time complexity of this algorithm. Well, the running time complexity of the brute force solution will be governed by this step, and the time it takes in order to generate all possible pair is n squared. Thereby the running time complexity of this algorithm is n square. Okay, so that's about the brute force solution, folks. Now let us discuss the optimal solution for this problem. So in order to understand the optimal solution, let us take an example. So let's take the same example where n is equals to 9 and the elements of the array ARR are, so these are the elements of the array ARR. So the problem with the brute force solution is we wanted to compare all possible pairs, right? So this is the problem with the brute force solution, or this is the reason why our running time complexity was going into n squared time, right? Now the optimization is basically, or is there a way by which I'll be able to compare the relevant pairs only, not the irrelevant pairs. Okay, so the optimization here is compare the relevant pairs and not the irrelevant one. Okay, so we would like to compare the relevant pairs, and as much possible we would like to skip the irrelevant pairs. So let us see how we will be able to do this optimization. So in order to understand how we will be able to do this optimization, let us take the same example which we have, where the array A contains 9 elements and the elements of the array are. So these are the elements of the array, and let me write down the indexes as well. Now here if you see, let us say we are at the first element here, which is 34, and for 34 the irrelevant pairs are 34, 8. So this is an irrelevant pair, 34, 10, and so on, right? So these are some irrelevant pairs. And what is the relevant pair for us? Well, the relevant pairs for us is 34, 80. Okay, so this is my relevant pair. So in order to make the comparison only with relevant pairs, what we are going to do is we are going to maintain a stack which will contain the maximum element so far. Okay, so what do I mean by this is, so this is my stack, and what we are going to do is we are going to iterate the elements of the array in backwards order. Okay, so we are going to iterate in this fashion. Now let us populate it. Right now the maximum element is what? 1. So this contains 1. What is the maximum element till here? Well, the maximum element is 33. What is the maximum element till 6th index? Well, the maximum element till 6th index is 33. So the maximum element so far is 33. Now what is the maximum element so far? Well, it is 80. What is the maximum? Now since 80 is the maximum element, so all these values will be 80. So this we understand that there is a stack which contains all these elements. Well, in a more optimized way, the stack, rather than repeating the elements, right, 80, 80 and 33 and 33, what we can do is we can store the element just once. So let us say our stack will be there, and the stack will contains only elements which are, what are the elements? Well, 1, and then so like one was the first maximum element, the second maximum element is 33, and the third is 80. So the stack, rather than containing all those elements, will contain only these elements. Okay, now what we are going to do is we are going to iterate on the elements of the array from 0 to all the way till n. Okay, so now let us iterate on the elements of the array and see how we will be able to find or compare only the relevant pairs. So far we have this array with us and the stack with us. Okay, so we are starting with I is equals to 0. Now the element AI is 34. So for the first element 34, what is the relevant pair which we have? So corresponding to 34, the top element of the stack will contain an element which can form a possible relevant pair. So for instance, in this particular case, the top element of a stack contains 80, right? And remember, this stack is in increasing order, right? If you see, that is how we have maintained this stack. The stack is in increasing order. Okay, so now the top element is 80. So 34 and 80 forms a pair, and this is a relevant pair for us, right? So as you can see, we have not compared 34 with any of the intermediary elements. Rather than that, I have compared it with the top element of a stack. That gives me a relevant pair. Now, so 34 and 80 is a relevant pair for us. 34 is pointed by the index I, and 80 is pointed by my top of the stack. Now I have an option of increasing I. So I have an option of increasing I, or I have an option of increasing top, right? So these are the two options I have, and let us see which option are we going to choose. Okay, so right now we are at 34, 80. So we know that 80 is the largest element of the array. So it might be possible that 34 may form a possible pair with the second largest element of the stack or the second largest element of the array. Okay, it might be possible that this is the case, right? And remember, while forming a stack, we have iterated on the elements of the array in the backward orders. So if 80 is at this position, which is here, then it might be possible that there are elements less than 80 but greater than 34, which is there in this portion of the array. Okay, which is there in this portion of the array. Okay, and if at all there exists such an element, then that element will be on the stack. Okay, so because of which, in this particular case, we will not go ahead and increase I, rather than we will go ahead and increase top. Okay, so now what happens is that the next element, so first what we are going to do is we are going to pop 80 from the stack. So now our stack will look something like 1 and 33, and the next pair will be something like 34 comma, what is the top element of the stack? Well, the top element of the stack is 33. So the stack right now contains, so remember 80 is something which we have popped out, so 33 is what we have, and the pair which we have, so we were at index I equals to 0, and now the top has been updated, so the top points to 33. So now the pair is 34 comma 33. Here, as you can see, 34 is not less than or equals to 33. So it does not meet our condition. Now, since it does not meet our condition, what we are going to do is we are going to increase our I. Increase I. Okay. So now we will be I is equals to 1, which in that case, the pair will be 8 comma 33. Now, since 8 is less than or equals to 33, so this forms a relevant pair for us. Again, this is a relevant pair. Similarly, in the first case when we form the pair, so this case here, if you see, this is a relevant pair because 34 is less than or equals to 80. Now, since this forms a relevant pair for us, so towards the end we will go ahead and compute j minus I also. But for now, let's proceed forward. So 8 comma 33 forms a relevant pair, right? So like this is my 8 and this is my 33. So it might be possible that there are elements which is towards the right of 33, which can form a possible pair or which can form a relevant pair. And clearly, if there exists such a pair, then the size of that pair, so this distance I am talking about, this distance of that pair will be greater than the current distance which we have. So now let us do that. Now the next greatest element is there on the top of the stack. So what we are going to do is first we are going to go ahead and pop 33 from the stack. So now the stack contains only one element, which is 1, and now the pair becomes 8 comma 1. Now since 8 is not less than or equals to 1, so this is not a relevant pair, and as soon as we get to a position where we don't get a relevant pair, we go ahead and increase our I. So we again go ahead and increase our I. Now the next element is 10. So let's take the 10 with us. 10 comma 1 again does not forms a relevant pair. So this is not a relevant pair. We went ahead and increase our I and we took the next element. The next element is what? 3. So the next element is 3. 3 comma 1 again not a relevant pair. So we move forward. And similarly, we keep on moving forward. So let me have this. So let's move forward here. Now from 3, 2 comma 1, this is again not a relevant pair. We move forward. 80 comma 1, not a relevant pair. We move forward. 30 comma 1, not a relevant pair. We move forward. Then 33 comma 1, not a relevant pair. We moved forward. And then it comes to the last position, which is 1 comma 1, which is a relevant pair. So in this way, rather than iterating on all possible pairs or all possible irrelevant pairs, we have optimized our code such that we iterate on a relevant pairs only. Or in the case, even if we are iterating on irrelevant pairs, in that case, we are just doing it once and then we are moving it to the next element. So we have iterated on all the elements of the array, and now let us find out the maximum of j comma I. So see, this is a relevant pair for us. and here j minus I will be equals to 0, right? Because the ith and the top element are pointing to the same element. This again is a relevant pair, 8 comma 33. So now let's take the corresponding indexes. So 8 is 1 and 33 is 7. So this is equals to 7 minus 1, and this will be equals to 6. The other relevant pair which we had is this 34 comma 80. So 34 is here and 80 is here. So this is essentially 5 minus 0, which is equals to 5. And we wanted to maximize it. So the maximum value is this 6. So this is what we are going to return. So that's about the explanation, folks. Now let us go ahead and write a pseudocode for this. So let's say we want to compute the max index, and the array A is given to us and the number of elements is given to us. Now let us see what we can do. So the first thing which we want to do is we want to form a stack, and the stack contains the maximum element so far starting from the ending index. So here what we are going to do is we are going to iterate the array backwards. So for I in, and this since it starts from backwards, so n minus 1 all the way till 0 on the step of minus 1. Now let's append the maximum value here. If stack is empty, so if stack is empty simply means that the length of stack is 0. So if length of stack equals to 0, or the ith element is greater than or equals to the top element of the stack. So the top element of the stack can be found out using this, right? And then the element itself. So remember, on a stack, rather than storing element, we will be storing the index, because we want to find the difference between the indexes, not the elements. And then if these conditions, if either of these conditions are satisfied, then we are going to go ahead and append index on the stack. From second, third and fourth step, we will be able to populate our stack. Once we have populated our stack, then we are going to go ahead and iterate on the elements of the array from the 0th index. And also we will have something called as global max. This will be our answer essentially, and we are going to set it with negative infinity, the initial value. Let's iterate on this. So let's iterate using while loop. While I is less than n and stack is also not empty, right? If the stack is empty, then there isn't any pair we will be able to form. So these are the two conditions which needs to be satisfied here. So now we are at this position. So now we are iterating on the elements. So ith element and the stack forms a pair for us. Now we are going to check whether the this pair is a relevant pair or not. It is a relevant pair if this condition is satisfied, right? And if it is a relevant pair, then we are going to compute the, so I'm going to compute the current max, right? So I'm going to compute the difference between the indexes, right? So remember, the difference is stack dot pop minus ith element. So we will go ahead and compute the difference between this, and remember here we have popped the element also. So now in the next iteration we will be computing with the next element of the stack rather than the current one. So after doing this, so in the ninth step we are going to check that if current max is greater than global max, then let's go ahead and update our global max. And after doing this, here we want to continue. This continue is basically because we want to remain at the ith index. We want to be at the ith index. I want to compare it with the next element of the stack. That is why I have put a continue here. And let us say if this condition is not satisfied, if this is not a relevant pair, then we will go ahead and update our I. So we are going to go ahead to the next element and we are going to check if this forms a possible pair or not. And towards the end, we are going to return our global max. So that's about the pseudocode, folks. Now let us see how we have implemented this in Python. So the code is the same as of our pseudo code. Here stack is this, and then we are iterating on the elements of the stack backwards, and we are updating the stack. And remember, the stack essentially stores the value, the maximum element so far. And then we are iterating on the elements of the array. If the pair forms a relevant pair, then we are going to go ahead and compute the max of it, the current max. And if the current max is greater than the global max, then we will go ahead and update our global max. And if this is a relevant pair, then it might be possible that the next element of the stack also forms a possible pair, because of which we are not updating our I and we are moving to the next element of the stack. Otherwise, if this does not form a relevant pair, then we are going to go ahead and increase our I by 1, and we will go ahead and check if the next element forms a possible or a relevant pair or not. And towards the end, we will go ahead and return global max. So that's about the code, folks. Now let us go ahead and submit our solution. So our solution got accepted. That is all from this video, folks. In case if you have any question or comment regarding this video, please feel free to use the comment section and I'll try to address them. Thank you.